Recording in progress.
Slope of a line is represented by the letter M. If a line is rising from left to right, it is also said that this is the graph of a function that is increasing, meaning its y values or function values are increasing from left to right as x increases, and the slope M is positive, greater than 0. If a line is falling from left to right, it is also described as being the graph of a function that is decreasing. So the function values or y values are decreasing as x increases from left to right, and the slope M is less than 0. Slope is a negative number. If the line is horizontal, then the slope is 0. If the line is vertical, then the slope is undefined. Now we're going to derive the slope formula. So here are coordinate axes and a generic line with a positive slope. Let P1 and P2 be 2 points on the line where first point P1 has coordinates x subscript 1 and y coordinate y sub 1, and a second point P2 have x and y coordinates x subscript 2 and y sub 2. So now we're going to form a right triangle. So this horizontal leg is perpendicular at 90 degrees to the vertical leg. And we now want to compute the length of the legs of the right triangle. So we're going to extend some vertical lines here to show x sub 1 is a coordinate, and it's also the horizontal distance from the y-axis. X sub 2 is an x coordinate and also represents a horizontal distance from the y-axis. And when you subtract length x sub 2 minus length x sub 1, you get this distance x sub 2 minus x sub 1, which translates to the length of the horizontal leg on the right triangle. And between the 2 points P1 and P2, that's also called the horizontal run. And in a similar way, we create these horizontal lines and then note that y sub 2 represents a vertical distance from the x-axis. Y sub 1 also represents a vertical distance, and when you subtract length y sub 2 minus length y sub 1, you get this expression, which is the vertical distance that translates to the length of the vertical leg on the right triangle. So between P1 and P2, there's a vertical rise, y2 minus y1. And now we can talk about comparing the rise to the run and writing a ratio of rise over run. And that leads to the slope formula, which says, given two distinct points, P1, whose coordinates are x sub 1, y sub 1, and a second point P2, whose coordinates are x sub 2, y sub 2. The slope of the line M is the ratio y2 minus y1 divided by x2 minus x1. And since division by 0 is undefined, we have a technicality that the denominator x2 minus x1 cannot be equal to 0, which occurs when you have a vertical line, then the x coordinates are the same, and when you subtract the x coordinates, you're going to get 0, and division by 0 is undefined, and that's why the slope is undefined for the vertical line. Also, y2 minus y1 is called the change in y, and that's represented by this Greek letter delta y. Delta means change. So delta y is change in y. And delta x means the change in x. Example, compute the slope given 2 points P1, coordinates -2, 3, and a second point, coordinates -2, -1. And we can label these coordinates x sub 1, y sub 1, x sub 2, y sub 2. And applying the slope formula, the slope of the line that contains these 2 points is, substitution, -1 minus 3 divided by -10 minus -2. So now we're going to do the subtraction and simplify. So the numerator is -4, denominator -8. So the slope is +1/2. Note that slope is also called the rate of change of y with respect to x. Next example, graph a line containing the point -1, 2 with a slope of -4/3. So let's write the opposite of 4/3 as -4 divided by +3, which is also the same as +4 divided by -3. Plotting the first point or the given point at -1, +2 as the starting point, we can use the ratio -4 over +3 means we're going to go vertically down 4 units and then horizontally to the right 3 units. So the x coordinate will be +2. Or going back to the given point, we can go up 4. So then we'll be at 6. And then left 3. So the x coordinate will be -4. And then we can draw a line through the 3 points. And there is the graph of the line containing the given point with the slope of -4/3. The equation of a line in point slope form is y minus y1 equals the slope times x minus x1, which is derived in the following way. If we have an arbitrary line whose slope is given, so let's assume slope is given. So we know what that is, or we can compute it easily from a given graph. And let's say we're given a point on the line whose coordinates are x sub 1, y sub 1, and all other points are represented by this general point whose coordinates are variable x and y. So this second point is a general point representing all other points besides the given point. And x and y are going to be what we're going to substitute for x sub 2 and y sub 2 in the slope formula. So since the slope formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1, we're going to substitute. For y sub 2, we're going to substitute the general y coordinate, which is y, minus the given y coordinate y sub 1 divided by x sub 2, which is variable x minus x sub 1. So this equation is a proportion, which is two equal ratios. M is understood to be over 1. So we can apply the cross product rule and multiply diagonally. And we get y minus y1 times 1, which is just y minus y1. And then m times the denominator x minus x1. So that gives the equation of a line in point slope form. So next we have the equation of a line in slope-intercept form, which is y equals m times x plus b. And again, we're going to have some generic line. It has a y-intercept at b, x coordinate of 0, so that's 0 comma b as the y-intercept. And the slope is again given. So we're going to let a second point be a general point with variable coordinates x and y, and these are going to be x sub 2 and y sub 2 in the slope formula. And the y-intercept at 0 comma b, those coordinates are going to be x sub 1, y sub 1 in the slope formula. So slope is y2 minus y1, so that'll be variable y minus b divided by variable x minus 0. And that simplifies to slope equals y minus b divided by x. Again, m is over 1, so we can diagonally cross multiply, and we get y minus b times 1 equals m times x, and that gives y equals slope m times x plus the y-intercept b. Example, given 4x minus 2y equals -2, find the slope of the line in the y-intercept. So just as above in the middle of the screen, the equation is solved for y, or y is isolated. We take this given equation and isolate y, we can figure out the slope. It's going to be the coefficient of x, and the y-intercept is b. So first step is to subtract 4x from both sides. So we get -4x on the right side minus 2. And if we divide all terms by -2 and simplify, then we have y equals +2 is the slope times x minus a negative becomes +1. So this is slope-intercept form, y equals mx plus b. Therefore, the slope is +2, and b is 1, so the y-intercept is 0, 1. Intercepts are intersection points of a graph and the coordinate axes. So wherever a graph crosses the x or y axis, those are intercepts. And a y-intercept will always have an x coordinate of 0, and an x-intercept will always have a y coordinate of 0. So for example, say we have some line. It's going to intersect the y-axis when x is 0, and intersect the x-axis when y is 0. So we use those facts to answer this question. What are the intercepts of this given equation, and find a checkpoint? So we're going to let x equals 0, which just means substitute 0 for x, and that will eliminate that x term. And now we have -2y is equal to -6. So y equals +3. And 0 is x, y is 3. So those are the coordinates of the y-intercept. So next, we're going to substitute y is 0 to find the x-intercept. So letting y equals 0, we have -3 x minus 2 times 0 equals -6. That eliminates the y term. So -3x equals -6. X equals +2. Therefore, this intercept is occurring at 2, 0. So if we were graphing, we would have 2 points, and a checkpoint would be a third point, which should be on the same line or collinear with the intercepts. So we can choose any value not already computed. So for example, we can choose for x or y any number except x is 2 or y is 3. For example, we can say choose x equals 1. So letting x equal 1 to find a third point on the line, we have -3 times 1 minus 2 times y equals -6. So -3 minus 2y equals -6. -2y equals -3. Divide by -2, so y equals +3/2, or 1.5, or 1.5. So when x is 1, we have y is 1.5. So this third point should be collinear on the same line with the intercepts. If not, then there is an error somewhere that we'd have to then find. The equation of a line in standard form is ax plus by equals c. A is a positive number greater than 0. A, b, and c are real numbers, and they're usually integers or fractions. Parallel lines are coplanar, which means they lie in the same plane and have no common point, no intersection point. Let's define L1 to be a first line and L2 to be a second line. If the lines are parallel, we have this symbol. We would say L1 is parallel to L2. And if the lines are parallel, if that's a true statement, then it is true that the slopes are equal. So m sub 1, slope of line 1 is the same as the slope of line 2. Conversely, in the opposite direction, if slopes of two lines are equal, then going right to left, we can conclude that the lines are parallel. To show parallel lines, either we can use symbols like a pair of arrowheads, or sometimes we'll use just what look like squiggles, means parallel lines. Determine if line 1 is parallel to line 2. The lines are parallel if their slopes are equal. So given these two lines, we're going to solve for y to get them in slope-intercept form, y equals mx plus b, and we can determine the slopes, compare the slopes to see if the slopes are equal or not equal. So line 1, solving for y, we have 2y is equal to negative 6x plus 0, which we can ignore. And if we divide by 2, we have slope of negative 3. Y equals negative 3x. For the second line, L2, if we solve for y, we have negative y equals positive 3x plus 3. We want to solve for y, not negative y, so we multiply both sides or multiply every term by a negative 1. That will change the sign on all the terms. So y equals negative 3x minus 3. And therefore, the slope, which is the coefficient of x, is negative 3. So the slope of line 2 is negative 3, and the slope of line 1 is negative 3. We have equal slopes. So since the slopes are equal, slope 1 is the same as slope 2. The lines are parallel, so line 1 is parallel to line 2. Lines or line segments can be mutually perpendicular, and the symbol for perpendicular is an upside down looking T symbol. And to show perpendicularity, or the intersection of lines or segments forming 90-degree right angles, we can use small squares to indicate 90-degree angles. One line has a positive slope, so line 1, M1 is positive, and the other line, line 2, has a negative slope, so M sub 2 is less than 0. When two lines or line segments are perpendicular, we can write the following statement. Line 1 perpendicular to line 2, if that's a true statement or can be shown to be true, then one slope is the negative reciprocal of the other slope. So they'll be opposite in sign. One slope is negative, one slope is positive, and they will be reciprocals, negative reciprocals of one another. If we multiply diagonally, we have perpendicularity. If true, then the product of their slopes, M1 times M2, is going to equal negative 1. Conversely, if the slopes are negative reciprocals, or the product of their slopes is negative 1 is true or can be shown to be true, then we can conclude perpendicularity. For example, given two lines L1 and L2, with these given equations, determine if the lines are perpendicular. The lines are perpendicular if it is true their slopes are negative reciprocals. And the strategy is to solve for y, get y equals mx plus b form, so we can determine the slope, compare the slopes, and then conclude either perpendicularity or not. So the first line, if we solve for y, we have negative 4y is equal to a negative 2x plus 8. And if we divide by negative 4, each term, then we have y equals positive 1/2 times x plus negative 2. So the slope of line 1 is positive 1/2. For the second line, L2, we'll solve for y. So we have negative 4y is equal to a negative 4x minus 8. Divide by negative 4 every term. And then simplify. So subtract 8 divided by negative 4. Y equals positive 1. X minus a negative becomes plus 2. So the slope is positive 1, the slope of line 2. The slopes are both positive and they're not negative reciprocals. Therefore, the lines are not mutually perpendicular. Conclusion, since the product of the slopes m1 times m2 is not negative 1, conclusion, line 1 is not perpendicular. So upside down T and then a slash through it means not perpendicular to line 2. Example, find the equation of the line parallel to line 1, which contains a given point, negative 1, 2. For lines to be parallel, their slopes must be equal. So line 1, if parallel to line 2, if true, then slope 1 will equal slope 2. And conversely, if slopes are equal, then the lines are parallel. So the connection is to find the slope of the given line and solve for y. So we have negative 3y equals negative 6x plus 12. If we divide by negative 3 every term, and simplify, we have y equals positive 2x plus negative 4. And therefore, the slope is positive 2. So the parallel line has the same slope of 2 and contains a point of negative 1, 2. To get the equation in point slope form, which is y minus y1 equals the slope times x minus x1, we use the slope of 2, m is 2, and we'll use the given point. Negative 1 is going to be x sub 1, and positive 2 will be y sub 1. And make the substitutions. So we have variable y minus 2 equals slope of 2 times variable x minus negative 1. Simplifying just a little bit, y minus 2 equals 2 times x plus 1. So that's the equation in point slope form. If you're asked for slope-intercept form, then you have to solve for y. So we would distribute the 2. So we have y minus 2 equals 2 times x plus 2. So y equals 2x plus 4 is the equation of the line in slope-intercept form. Find the equation of the line perpendicular to the line x minus 2y equals -5, which contains the point 0,4. If the lines are perpendicular, then their slopes are negative reciprocals. In symbol form, we have L1 perpendicular to L2. If true, then M1 is the negative reciprocal of M2, or the product of their slopes is -1. So since the connection of lines that are perpendicular is their slopes, we're going to solve the given equation for y to find the slope. So we have negative 2y equals -x minus 5. We multiply all terms by -1. That will change the sign on all terms. So positive 2y equals positive 1x plus 5. Divide by 2. So simplifying, we have y equals positive 1/2 x plus 5/2. Since the slope is positive 1/2 for line 1, the other slope for the perpendicular line is going to be -2. So using the equation of a line in point slope form, which is y minus y1 equals slope times x minus x1, and knowing that m2 is -2, we can substitute m2 is -2, and for the given point, which was 0, 4, 0 will replace x sub 1, and 4 will replace y sub 1. So the equation of the line perpendicular is y minus 4 equals slope -2 times x minus 0. And if we want to solve for y, we have y minus 4 equals -2 times x, or y equals -2x plus 4 is the equation of the line perpendicular containing the given point. New example, find the equation of a vertical line that contains a point at 4, -5, so containing x is 4, y is -5. So let's draw a picture which is worth many words. 4, -5, roughly. So let's let this be 4, x is 4, and -5. So since the line is vertical, it will contain the given point, and every point on this vertical line is going to have an x coordinate of 4. So since x equals 4 for every point on this vertical line, the equation of the vertical line is x equals 4. And in general, all vertical lines are of the form x equals a constant. So the graph of x equals a constant is always a vertical line. In a similar way, the graph of y equals a constant is always a horizontal line with a slope of 0.